So let's talk about Retrieval-Augmented Generation, or RAG. You probably heard the term, and for good reason. It has quickly become one of the most essential technologies for making AI more reliable, more knowledgeable, and frankly, more trustworthy. Today we're going to unpack how this seemingly simple idea exploded into the engine that's powering the next wave of AI agents.
All right, here's the plan. We're going to start with the core idea. What is this thing, really? Then we'll trace its wild evolution. We'll look at the modern toolkit developers are using today, and then get into the really tough trade-offs you have to make in production. And finally, we'll take a look into the crystal ball at the future, Agentic RAG.
Okay, so first things first. Let's get right to the heart of it. Why does RAG even exist? Well, it all comes down to a really fundamental problem with large language models.
And this image just nails the problem perfectly. Think of a standard LLM as a genius who read every single book in the library, but only up until 2022. And since then, they've been locked in a room. They have no idea what's happening in the world right now. So this leads to answers that are out of date, or worse, what we call hallucinations, where the model just confidently makes stuff up.
And that's where RAG comes in. It was first formally introduced by Lewis and his team back in 2020, and it's a brilliant solution. It's like giving that genius in the room an internet connection. You're basically allowing the LLM to have an open book exam. It can look up fresh, relevant facts from some external knowledge base before it even tries to answer your question.
In theory, the process is beautifully simple. It breaks down into 3 pillars. First, it retrieves relevant information. Second, it augments your original question with this new context it just found. And finally, it generates an answer that's actually grounded in the evidence. Retrieve, augment, generate. Simple, right? Well, that simple idea did not stay simple for very long. Let's look at how it evolved from that basic concept into a really sophisticated engineering discipline. Because believe me, this journey has been incredibly fast. I mean, look at this. In just a few short years, RAG went from a niche academic paper in 2020 to being the absolute backbone of the AI agents we're seeing emerge today. You can see this massive acceleration from a basic idea to a complex, almost autonomous system. And you can really see that jump visually right here. On the left, that's naive RAG, a simple, straight line. But on the right, you have advanced RAG, which adds these crucial steps before and after the retrieval part. And let me be clear, today, that simple version on the left is pretty much considered technical debt. All the serious production work starts with the more complex architecture on the right. So what were the big innovations that made this shift happen? 2 key things: hybrid search and re-ranking. Hybrid search means you're not just looking for keywords, you're also searching for the underlying meaning, the vibe of what you're asking. And re-ranking is all about improving that signal-to-noise ratio, making sure the LLM gets only the absolute best, most relevant info to work with. Now, if you're wondering how much of a difference that re-ranking step makes, well, here's a number for you. Just by adding a re-ranker to filter and prioritize your search results, you can improve recall, that's the ability to find all the relevant stuff, by up to 48%. That is a massive gain in accuracy. But the evolution didn't stop there, not by a long shot. It's brought us to where we are today, which you could call modular RAG. Just looking at this diagram, you can see the whole paradigm has shifted. A modern RAG system isn't a rigid pipeline anymore. It's this flexible plug-and-play architecture. So think of it less like an assembly line and more like a workshop, just filled with all these specialized interchangeable tools you can use.
And what this modularity means is developers can now plug in all these powerful components. You can have a tool that rewrites the user's query to make it better for your database. You can have another tool that criticizes the documents that come back. You can even have a reflection module that lets the system learn from its past mistakes and get smarter over time.
But, and this is a big but, taking this incredible workshop of tools and actually building a real-world product with it forces you to face some very, very hard trade-offs. So here's the most important thing for any engineer out there building a RAG system to remember. You are always governed by the pick 2 rule. You simply can't have it all. And this is what we call the Cal triangle: cost, accuracy, and latency. You have to pick which 2 you want to prioritize. You want the absolute highest accuracy, it's going to cost you more, and it's going to be slower. You need a lightning-fast response for your users? Well, you might have to give up a little bit of accuracy. Every single production system is a careful balancing act between these 3. This table does a great job of showing those trade-offs compared to another technique called fine-tuning. With RAG, you get incredible data freshness. It's almost instant, and you can cite your sources, which is huge for trust.
The catch? It has higher latency because of that real-time lookup step. It's just slower.
And the cost implications are absolutely real. If you move from a standard RAG system to something more advanced, like GraphRAG, which understands the relationships between documents, not just the documents themselves, you get much better reasoning. But that comes with a price tag that can be 3 to 5 times higher in compute costs.
Okay, so where is all of this incredible development headed? Well, it's pushing us straight towards the agentic frontier, where RAG isn't just a simple lookup tool anymore, it's becoming a core part of an AI's actual reasoning process.
These future systems work on what's called a think, act, observe loop. The AI autonomously thinks about a plan, then it acts by using a tool, like our RAG system, and then it observes the result to figure out what to do next. It's this continuous, powerful cycle of reasoning and action.
And this quote right here, it really nails the key to building these robust systems. The future isn't just about finding a fancier algorithm, it's about taking a data-first approach. You have to deeply understand the knowledge you're working with and let that shape how you build your entire pipeline. And all of this leaves us with the final and most crucial question for the entire field. As we build these incredibly powerful and autonomous agents, what kind of frameworks and guardrails do we need to invent to make sure they're not just accurate, but that they're also transparent, safe, and ultimately trustworthy? Because that, right there, is the challenge that's going to define the next 5 years.